What is the order? Yeah, order of metallic character.
So as size increases,
Yes, yes.
metallic character also increases, I think.
Yeah. So means you tell me in the group. Okay, that is what correct one. You said very correctly. What will happen in the group? In group, if I am talking about in group. So what will be there, the metallic character in group? If you are going down the group, what will happen? Metallic character. Suppose I am taking lithium, then sodium, potassium. Here is rubidium, cesium, and francium. What will happen to metallic character of these elements?
It will increase.
Yeah. Why it will increase?
Because the number of shells increase.
Yeah, that is okay. Size increases. So what will happen? So what? Size increases means that is okay. Size or the number of cell increases. Number of cell increases. It doesn't mean that metallic character also increases. But metallic character is what? Tendency to lose electron. Tendency to lose electron. So how can you correlate these things? How can you correlate these things?
Well, the more shells you have,
yeah, attraction between nucleus and outermost electron. What will be there? Outermost electron will increase or decrease? Decreases. Okay. If the attraction decreases, it means it become easy to lose electron or difficult to lose electron?
Easy
to lose electron. So that is easy to lose electron. And what is metallic character? You told me tendency to lose electron. Greater the tendency to lose electron, higher the metallic character. Yes or no?
Yes.
So this is the higher metallic character means metallic character increases. Higher metallic character increases. Okay, what will be there in the period? This is the group I know you told me. What about the period? Can you tell me in the period? Okay, period.
It means the same.
Period means left to right. Period means what you know now? Left to right. Okay, and group means top to bottom. Here is this is group means top to bottom. Top to bottom. Okay, so this is. Now we were talking about in period. Suppose I am taking lithium, beryllium, boron, carbon, nitrogen, oxygen, chlorine, and chlorine. So what the order of metallic character? You let me know. Left to right.
It's constant, no?
What is constant? That is the shielding effect is constant. Left to right, what is there? You can say number of cell is constant means shielding effect is constant.
Yeah.
But we are talking about metallic character. Shielding effect constant. What about metallic character? It is going to increase.
Because the force of attraction increases.
Thank you very much. You are saying force of attraction increases. Okay, attraction increases. A force of attraction increases means tendency to lose electron. What will be there? Tendency to lose electron. Increase or decrease? Decrease. Thank you. So now, if tendency to lose electron decrease means metallic character increases. Metallic character decreases. Yes, na?
Yes.
Metallic character decreases. So these were the concepts we study. Now we are going to study another. Can I read this?
Wait, no. Okay, you can erase.
And the last page, this one.
No, wait. Okay, done.
One question, please tell me the one question. Very short question I'm asking you. Okay, which have highest metallic character? They are asked which have highest metallic character. Metallic character. Okay, this is the question. And in this one, they are talking about lithium. Then they are talking about the magnesium. This is the magnesium. Then they are talking about the barium. Then they are talking about the aluminium. And last one is gallium. Okay, so this is A. Here is B. This is the C. This is the D. And this is the E. Yeah, tell me which you can get the answer. Can you pick the answer? You can guess the answer.
Is it lithium?
Lithium.
Yeah, I don't know. Wait.
See,
Where?
top to bottom increases. Top to bottom increases. Top to bottom increases. Okay. I and C means increases. Left to right means decreases. Okay. So now you should know what is the position of these elements. Okay. Then only you will be able to understand. If you are knowing the position, then it can be little bit easy to understand. Now you see.
But okay, yeah.
Tell me. If you are telling, you can tell me. Right.
Is it C?
See, yeah. Very good. How you got the answer?
Well, I thought lithium because it's the most left, and barium is like one is in the second group, so I don't know.
Okay. Gallium. See, these are the elements. Up here you see, this is the group number 1, this is 2, and this is group number 13, right? Yeah. Now, if you are going down the group, so here is period 1, you know, P1, and here is going to be P2, here is going to be P3, here is going to be P4, here is going to be P5, here is going to be P6. Now locate the element. Okay, in the exam you need to locate faster. This is the one element. Another element is this one. Okay, last one is here. Okay, so another is aluminium. These are there, and here is. Up see, left to right decreasing. Yes, or no? Left to right decreasing means this cannot be answered. This cannot be answered because acha, if you go this one, you see this period. This is also not possible. And if you are going this one left to right, so and top to bottom increasing, so it is on the top, so it cannot be answered. Yes or no?
Okay, yeah.
So if you are going down the group, which is the downmost, this is the barium. Yes or no? Down the group is barium.
Okay.
So this will be our answer. Yeah. This will be, or without confusion, you can write this one. Are you be able to understand?
Yeah. Yes.
Can I erase? Okay. So this type of question asked in your exams, you take care. Next one is ionization energy. Ionization energy. Have you heard about this one, ionization energy?
No.
Okay. But you can guess now. Ionization potential.
Can I guess?
Yeah.
Well, I recognize the word ion, which is negatively or positively charged.
Yeah.
Element, yeah.
Very good.
So maybe it's the possibility for an element to become an ion.
Yeah. See, these all are there. Okay, very good. You try very well. See, they are the same name are there for ionization enthalpy. Either they can ask in the ionization energy, that is IE, ionization potential IP, ionization enthalpy del IH. Del I for energy in ionization, H for enthalpy. Got it?
Okay.
So they are all together, they are the same thing. Okay. They are saying the amount of what the concept, the amount of energy, the amount of energy required. They are talking about amount of energy required to remove an electron. They are saying amount of energy required to remove an electron from an outermost cell, outermost cell of isolated gaseous atom. Isolated gaseous atom. Gaseous atom. Okay. Gaseous atom. Have you find the book? I have shared one book to you. Have you seen that?
Yeah.
Okay.
Yeah.
You try to purchase some online books, any online available test series. What the test is going on in no? You may be knowing that is what are the way of test for your coming exams. Okay. So we can practice also what type of questions coming up. If you find any type of question from your seniors or your relatives, just send me that questions. So you try that question and send me also. So if any problem will be there, I will let you know also. Okay. So now see. So the first of things you should know, isolated. What is meaning of isolated? Isolated means alone. Yes, yeah, no. Alone means what? This is H2. It is the combined. Yes, na. H2 is combined. But H is what? That is, if you are talking about alone means what? That is H. Yes, yeah, no. So that is, this is the alone. This we are going to be. Either you say alone or isolated, both are the same word. Yes, yeah, no.
Yeah.
Okay. If suppose I am talking about Cl2. So Cl2 is combined, but Cl is what? This is going to be isolated. Yes, yeah, no?
Yes.
Now next one is gaseous state. Gaseous. Gaseous is called, that is loosely bonded state. Loosely, L-O-S-E-L-Y, loosely bonded state. Loosely bonded state. Loosely bonded state. So we cannot take, that is, suppose Na is there, state if you are talking about, okay, here I am writing the state. So if you talking about state, that is solid state, we need not to take. What we have to take? Na gaseous, right? If you are having aluminium, Al, we should not take the solid state. What we have to take? Al in the gaseous form, right? So firstly, you to understand this ionization energy, these are the term required. What are they are saying? The amount of energy required to remove an electron, one electron. To remove energy will be required because the electron are negative charge and nucleus is positive charge. So there is attraction force, yes or no, between electron and nucleus. Yes or no? So if you want to remove, you need to do some work, some energy is required, yes or no, to work against the attraction force. So that is the energy. Okay, they are saying that is the energy. The amount of energy required to remove an electron from an outermost cell of isolated gaseous atom is called ionization energy. Is called ionization energy. Are you be able to understand?
Yes.
Okay. So the term you need to be keep in mind. First one is isolated gaseous atom, and second one is outermost cell. Yes, yeah, no?
Yes. Okay.
Solve. Can you please write down this one?
I wrote.
All. Okay.
Yeah.
Thank you very much. So let me see. Suppose here is the mica. This is sodium. Okay. So sodium is having how many atomic number? 11. So it is configuration, that is 281, right? So this is the extra electron. Yes, yeah, no? One electron More than octet, yes or no? More than octet, yes or no? Okay. So they are saying, but you cannot easily remove this electron. So sodium, what they are going to do, sodium is removing one electron. How? By IE1, we are supplying the ionization energy. What you are going to do, first ionization energy. If you will write, because you want to remove only one electron, no? So first ionization energy you are supplying, first ionization energy. So what is going to happen? What is going to happen? Na will convert one electron, will lose. So it is converting one electron. Yes or no? So here is what is happening. Loss of one electron. Yes or no? Loss of one electron. Yeah. So this is this, that is ionization energy required to remove the electron, one electron. So this process is what is the here the removal of electron taking place. So this is what is called IE, ionization energy. Are you be able to understand this one?
Yeah, I think.
See the sodium is what? Gaseous state. One electron you remove. So sodium one electron gone. So that is Na plus. And if you see Na plus, if you talk about Na plus, so Na plus, how many electrons are there? 11 and one positive charge. So minus one. So total electron will be how much? 10 electron. Yes or no?
Okay. Yeah.
A 10 electron means configuration. If you are doing 2,8 and 2,8 is stable configuration. Yes or no?
Yeah.
Octet. So they are saying that is here the loss of electron taking place, one electron loss. So this is first ionization energy. To remove the one
Yeah,
electron, ask.
how did the electron, like, how was it lost?
You supply the energy now. How? See here, sodium is there. The first cell, that is 2 electron, right? Another cell, 8 electron. 1, 2, 3, 4, 5, 6, 7, and 8. And the last cell, how many electrons are there? 1 electron. What you did, you have supplied the energy. Yes or no? You supply the energy. Okay. So if you supply the energy, so what is happening? This electron is going to escape out. Escape. Okay, out. Escaped out. So now the C. So what is one electron escaped out? So sodium side you see sodium. Now how many cell will be there? Only 2. Yes or no?
Yes.
So there is loss of electron 3, 4, 5, 6, 7, 8. Okay, 2. Loss of electron and number of cell reduced. Here 3 cell are there, here now 2 cell. Yes or no? So here this is the configuration of Na and this is configuration of Na plus. Plus means what?
Okay.
When understood?
Yeah.
Okay, can you write down this one?
Yes. Okay, I'm done.
Thank you. Now let us try to understand the types of ionization energy. Types of ionization energy. Till now I am explaining the definition, types of ionization. Then we will go in the group and period. Types of ionization energy. So there are 3 types of ionization energy observed. First one is IE1. Second one is called that is IE2. And third one will call IE3. IE1 is called that is, this is called first ionization energy. First ionization energy, right? First ionization energy. This is. Second one is called that is second ionization energy. This is called second ionization energy. Okay. Now the last one is called third ionization energy. Okay. Third ionization energy. If you talk about third ionization energy, what is the meaning of this one? Okay. So if you talk about this one, first ionization energy, so amount of energy required to remove, the quantum energy required amount of energy required to remove what? To remove first electron. To remove first electron. And here is they are talking about amount of energy required. Amount of energy required. Amount of energy required to remove what? Second electron. Second electron. And last one, amount of energy required. Amount of energy required. Amount of energy required to remove what? Third electron. To remove third electron. Getting my point?
Yeah.
From isolated gaseous atom, that is the common in all. Okay. If you are talking
Okay.
about from isolated gaseous atom, from isolated, this is going to be gaseous atom. Isolated gaseous atom. They are the same. From isolated gaseous atom, that is same. Here is gaseous ion will be there. Gaseous ion. Okay, gaseous ion. And here also will be gaseous ion. Because after removing one electron, it will convert into ions. Is it okay? Can I give you the examples?
Yeah.
If writing finished?
No.
Slowly write, no problem.
Okay.
Okay, thank you very much. So this much is over. Now we are taking the example. Okay, I am taking the example of aluminium. Aluminium is at such 13, atomic number is 13, configuration. If you talk about the configuration, audible? Audible? Hello?
Hi. You left.
No, not left. It got disconnected. I don't know why it got disconnected. Extremely sorry for that. Okay. So that is, I was explaining first, second, and third. So I was taking the example aluminium. Aluminium is 13. So 13 means what? That is going to be 2, 8, and 3. So it is, you can say, 3 electron more than octet. Yes or no? More than octet. Yes or no?
Yes.
So if 3 electron
Yes.
more than octet, so to become stable, to become stable, to become stable, what? To become stable like noble gas. Like if you want noble gas. So if you want to become stable like noble gas, so it required to remove 3 electron. It required to remove 3 electron. Required to remove 3. Yes or no? To remove 3 electron. Yes or no?
Yes.
Okay. So 3 electron remove. It required to remove 3 electron. So what is going to, how it will be taking place? So aluminium is there. Aluminium, you got to know, that is gaseous atom. So if you want, if I want to remove the 1 electron, so which energy I need to supply? You can see this is, I am supplying IE1. So IE1 means that is called, that is first ionization energy. Yes or no? First ionization energy. Getting this one? First ionization energy. So if with the help of first ionization energy, it is converting Al plus 1 electron minus. If you are talking about second one, Al positive, from this one you are removing one more electron. So one more electron means IE2. So this is going to be second ionization energy. This is going to be second ionization energy. To remove second ionization means it is going to be Al2 plus, and here is one electron more. If you want to remove one more electron from Al2 plus, so what you need to give? I need to give IE3. Okay, third ionization energy. Third ionization energy, right? Third ionization energy. So it is converting Al3 plus plus 1 electron. So total 3 electron means that first ionization 1 electron remove at a time. Okay, so that is what.
Okay.
So are you be able to understand this one? Is it okay?
Yes.
Please, please have a note of it. Please write down this. Done?
No.
Okay.
Okay, done.
Okay. So what we are going to, I am erasing this one. Going for the variation of IE. Variation of IE in group. We are going to check what is going to happen. Variation of ionization energy in group. Can you guess what will happen in the group? It will. Is it easy to remove electron or the difficult to remove electron?
Easy.
Easy. So let me explain one more point here. That is star. Greater the energy required to remove electron. Greater the energy. Okay. Required. Greater the energy required to remove electron. Greater the energy required to remove electron. Okay. Higher will be ionization energy. Higher will be ionization energy. Will be ionization energy. Is it okay?
Yeah.
Ionization energy, if you talk about ionization energy proportional to what? Attraction force. Okay. Greater the attraction force, greater the attraction force, greater will be ionization energy. Next one. Ionization energy, if you talk about ionization energy, inversely proportional to size. Inversely proportional to size. You see, size is large, easy to remove electron, ionization energy will be less. If this more, this will be less. What will it? Is it okay? These are the factors.
No. What is the thingy mean? The symbol?
This is a star I wrote.
No. You wrote ionization energy something attraction.
Greater the
No, the second point.
Proportional sign.
Okay.
Proportional. This is proportional sign.
Okay.
Now, is it okay?
Yeah.
Okay. Now come to the point here. Variation of IE in the group, right? So in the group, how it will, you are saying, suppose I am taking lithium, then sodium, then potassium, rubidium, cesium. We are going up to here. So what is happening if you are going down that is size increases? Yes or no?
Yes.
Size increases. Okay. So second factor is what we are using. Effective nuclear charge. No. Effective nuclear charge. Effective nuclear charge. It will increase or decrease? Effective nuclear charge. Z effective is equal to Z minus sigma. Tell me. It will decrease or increase? Effective nuclear charge.
Decrease.
Decreases. Effective nuclear charge decreases. So effective nuclear charge decreases means attraction will decrease or increase? Attraction will decrease or increase?
Decrease.
Decrease. Thank you. So that is more energy required to remove electron or less energy required to remove electron?
Less energy.
Less energy. So less energy required to remove electron. So if less energy required to remove electron, so that is lower the energy. So IE will be high or less?
Less.
I will decrease down the group. Decreases down the group. Are you able to understand?
Yeah.
Thank you. Please make a note of it.
Okay. I finished.
Acha, ho gaya? Done. Okay, thank you. This one is over. Now, variation in period. Variation in period. Variation in period. This one we are going. Variation in period. So, in general, I'm writing this one. In general, ionization energy increases in period. Ionization energy increases in period. Ionization energy increases in period as effective nuclear charge increases. Effective nuclear charge increases. They are saying as effective nuclear charge increases. Effective nuclear charge increases. So more energy. So more energy required to remove electrons. So more energy required to remove electron. Required to remove electron. So they are saying that is more energy required to remove electron. So what they are in general, ionization energy increases in period as effective nuclear charge increases. So more energy required to remove electron. Hence, it's generally, not always, it generally increases. It generally increases with some exception. With some exception. With some exception. So if you are talking about lithium, then beryllium, then boron, carbon, nitrogen, oxygen, fluorine. So IE increases. IE increases. But how the order you see? This is okay. But here is this one. Then this one, then this one, then this one, then this one. See the order. It's very difficult to memorize. But I will explain you how. This is the IE increases. I will explain you how it is happening.
Okay.
Okay, thank you. So why it is happening, Mika? Can you tell me? Variation of ionization energy. See, it is changing like anything. It's not the regular. In general, it is increasing, but some exceptions are there. What can be the reason?
No idea.
No idea. Okay. Very frankly, you are saying no idea. Huh? Okay, good. See, if anything is stable, very much stable. So if the stable atom is stable, so energy required more or less. If the atom is stable, so more energy required.
Less.
Again, you think if anything is stable, so less energy required or more energy required?
More.
More energy will be required. Now, if anything is stable, so you need to supply more energy because these stable things never going to lose electron. Yes, yeah, no.
Oh, okay. Yeah. Yes.
Okay.
Yes.
So here I am writing that is rule for exception. Rule for exception. They are saying either half filled. Hello,
Yes.
is it visible to you?
Yes. Yes. It's visible.
But the screen gone. I don't know what happening. Screen disappeared completely. No idea what is happening. Yeah, now it's coming. Yeah, after 3 minutes, Mika, Please rejoin. This is going to disconnect. Okay, it is showing 3 minutes after it is going to disconnect. So better I am disconnecting, again you rejoin. Otherwise in the meet it will disconnect. So again you rejoin, please, with the same link. Yes, na?
Okay.
Okay.
Okay, yeah.